Alrighty, greetings, salutations, all those nice things. Welcome to the last two examples from 5.3, where we were talking about ambiguous case. And with ambiguous case, we had ways to determine how many possible triangles could be drawn from some given information. Right, with this information here, if it meets certain parameters, then it could be that there are 0 triangles, could be that there's 1, but it could also be that there are 2 ways to draw that. And as you may recall, just flipping back in the notes, that's from looking at, well, normally like B sine A if we're talking about triangles ABC. But here, since we have angle X, we're looking at sine X and multiplying that by Y, Y being the opposing here. And in that case, since that is 12 sine 35 degrees, which is like 6.88 and some change. Since that's our minimum possible length of x, and x does exceed that, we can say there are 2 solutions. Because there are 2 solutions, I'm dividing this whole page in 2. So I'm putting a line down the middle, and we're going to solve each of those possible triangles. One of those triangles is going to be entirely acute, and you can draw that if you feel it gives you a bit of a sense as to what's going on here. And that's this case where x is 35, the side opposite it is 7, and then I like to label the top left one as side y, meaning we've got angle y at the bottom and then angle z at the top. The other triangle is going to have an obtuse angle in it. And that's where this side x bends inward instead of outward. So we've still got those same labels, x, y, and z. 12 is still that upper leftish area. X is 35 degrees, and then side x is 7. Excuse me. And then this is where we're going to proceed from. So solving this for both of these cases, the first thing we're going to do is find angle y. One of those cases on the left side over here, that's done just by using the sine law. We know A over sine A is B over sine B, all that jazz. So phrasing it for this particular case, I'm going to say sine y over y is, sine x over x. Thus telling me that sine y is y sine x, 12 sine 35 degrees over x, which is 7. You can do the calculation of this. Sine y is equal to whatever decimal form this takes on if you want. Not really necessary. What is necessary is that you get the value of y. And punching that into your calculator, taking inverse sine of whatever decimal value you get here, this for me to the nearest tenth is 79.5 degrees. So that's how we find angle y in this particular triangle. We're also going to find it in that one. And that one, there's a number of ways to look at it. One is to note that you can play with this like a cast rule kind of thing and say, well, this is to be the quadrant 2 version. So it's still this idea that sine y is equal to whatever the decimal form of this is, but noting that it could be quadrants 1 and 2. The other way is to note that this angle y is going to be the supplement of that other angle. And there are plenty of other ways to look at it. The big key, though, is that this angle y is 180 degrees minus the other angle y. And we're going to be using 180 degrees like a couple times in this whole example. It's really necessary for you to parse apart what it's being used for in each instance. In this instance, It's because these two angle y's are supplementary. It's because of that cast rule. That's why this 180 is being used. And as a result from that, we just straight up get that y is equal to 100.5 degrees. And that's for this triangle on the right, the one with the obtuse angle. The next thing we can find is angle z, and that's because we have two of the angles. And remember, if we have two angles in a triangle, we can find the third just by noting that the sum of the angles has to be 180. So z for the first triangle is 180 degrees minus the 35 degrees for x and minus the 79.5 degrees for y, which gives us a difference of 65.5 degrees. So this 180 is being used because that's the sum of the interior angles of the triangles. That is not the same as this 180 being used over here. It's, again, very key that difference is noted. It is a common area where people do get confused. What am I supposed to be subtracting when and all that jazz? And it all depends on what information you have at every given point. Here again, we're finding z, and it's that same idea. We now have angle x, we have angle y. We're going to subtract those from 180 to find angle z. So z is 180 degrees minus x, which we have, and minus y, which we now have, which tells us that z is 44.5 degrees. Last thing to find. Sorry, very sorry about this. Last thing to find is side z, and that's with a little z, since it's a side. And for that, we're going back to sine law. You could use x's or you could use y's. I always recommend using exactly what's given to you in the question. It helps ensure the greatest amount of accuracy and precision. So, z over sine z is x over sine big X. And if we multiply both sides by sine z, we get x sine z, which was 7 sine, and now z here is 65.5 degrees. And then sine x is sine of 35 degrees. And now, straight jump to calculator. You plug that in, and you get some sort of value on it. I'm getting 11.1. And that same idea, that same method is used to find z in the other triangle as well. So, z is 7 sine... Did I screw something up here? No, I didn't. Right, sine z is moving over here. Oops. And z in this case is 44.5 degrees. And sine x is still sine 35 degrees. Straight punch into calculator. This z is 8.6. If you want, you can put a good old box around all your answers. Woo, nailed it. And there should be 3 things to find for each triangle, which is what we did. A little quick summary here. First, we found angle y, one directly through sine law, and then the other by supplementary angles or cast rule. Once we had that, we could find z. Our method for finding angle z was the same in both cases. It's just using that interior angle property of triangles. And then finally, finding side z, and same way for both cases, it's using sine law. So the only place these two triangles differ in terms of how we find their parameters is in that first step here, where we're looking at the two different angle y's. And again, either use cast rule or use or supplementary angles, but have some method of recognizing why we use 180 here and differentiate that from why we use 180 in that next step. That was a quick doozy of an example. Take a moment, try the other example. So yeah, try the example on the next page. Give it a solid, 7 minutes if you want, to pause the video once I'm done speaking here. Try the example, really work through it, see what you get, and then resume the video just to see if your answers match up with what I've got. All right, I'm assuming you've paused this video. Oh, look, I've already got a line drawn. Aren't I great? So you're dealing with triangle PQR. So we're going to take sine P and multiply that by Q. And that's 17.5 sine 27 degrees, which is like 9.2 and some change. Hold on. That doesn't work. Calculator. That's 7.9. Thank goodness, because that would have otherwise given us 0 triangles. 7.9 is the minimum possible length of P. P is more than that. It can ride the roller coaster. It's tall enough to ride the ride. So there are 2 possible solutions. One of those solutions will be entirely, will be this. Did it again. Acute triangle, and then the other one will be that guaranteed obtuse triangle. I always put the given angle on the left, just like the last example. I put the matching letter for the other side were given on the right, and then I throw in the last letter on the top. Worth noting, you don't need to draw these triangles if you don't want to, but if you find they give you a sense of what's going on, then I'd say go for it, right? You can keep labeling things as you go along. We start with the stuff we know. The 27 degrees, the 8.7 side, and the 17.5 side, right? And then as you find out more and more information, you can fill that into the triangle just to help yourself keep track. But again, don't have to. First thing I'm finding, one right angle, in this case angle Q. Hopefully you set this up using sine law. Q sine P is 17.5 sine 27 degrees over P, which is 8.7. Sine Y is like 0.918 and some change, but that doesn't matter. Or not sine Y, sine Q. So angle Q, you should be getting a value of 66.0 degrees. And recall this step differs for the other triangle. For the other triangle, we're just going to straight up say it's the supplement, which gets us 114 degrees. Oops. Gotta have that 0.0 since we're rounding to nearest tenth. That one's done. Next up, the last angle. That's straight up by using interior angle property. So we'll take away angle P, we'll take away angle Q. And for this triangle, I'm getting 87 degrees. Excuse me. Forgot that 0 again. Darn 0s. And the other triangle, 180 degrees minus 27 degrees minus 114 degrees. In this case, R is 39 degrees. And lastly, we're going to find that last missing side. Remember, for this one, technique same. So back to sine law. What do we have? We had P and sine P. So R is P sine R, which is 8.7 sine, angle R in this case, 87.0. There's lots of 8s and 7s in this question. And then angle P was 27 degrees. R is 19.1 for that particular triangle. For the other one, P sine R, 8.7 sine 39 degrees, all over sine P, so all over sine 27. And in this case, punching that into calculator, I'm getting 12.1. So that is how you solve triangles when there is an ambiguous case. It is super necessary to show that there are two possible solutions. So that's worth one of the marks. Your technique for finding angle Q for the left triangle is worth a mark. Your technique for finding angle Q for the right triangle is also worth a mark. This interior angle property for each one of these cases is worth half a mark. So a total of 1 for that step. So for the 1 for this step, 1 for this step, 1 for this step, and then combined total of 1 here. Looks like a shocked face. Now we're at 4 marks. And then last, a mark for sine law here, a mark for sine law here. So lots of marks available in this question. Know where they come from, and you'll have a much better idea as to how to proceed when you see that single 6-mark question on a test or quiz. That's all I've got. Thank you for bearing with me through this video. I hope it goes super well, and I will see you in the